Hello. Hello. Am I audible? Yeah. Hello. I hope the audio is okay. Yeah. Hello. Yeah. Good evening, everyone. I'm Rahul Mohnani, your maths educator. Today we are going to start a topic called as limits. Okay. Before that, let me just tell you, if you are willing to take a subscription for ISC plus ISC class 11 plus subscription, then you can use this code RMSIR. You can use this code RMSIR. Through this, you can enroll for the plus and you can get the 10% off. Along with this, there are benefits of plus. So we have a test series on the weekly basis, on the monthly basis also. Along with that, we have a entire syllabus coverage batch courses. So you can enroll for the batch courses also. Today's topic that we are going to start is the limits. In that, we'll be taking trigonometric limits. Okay, the major topic that we are going to discuss today is trigonometric limits. I hope the audio and this thing is okay. Just let me know if any issues are there regarding the audio. Okay, so let's start with the topic. We have started this batch on the 6th of October, in which these are the educators. We are covering the entire syllabus for class 11 students. Let's start with the limits and the trigonometric limits. So here as we have discussed in the previous session, like algebraic limits, 0 by 0 forms are there, right? 0 by 0 form, after that infinity by infinity form, and there are many other 7 different forms like 1 power infinity. These are indeterminate forms. So in trigonometric limits, we'll be discussing mainly on 0 by 0 form. Indeterminate forms are there. So 0 by 0 form we are going to discuss in the trigonometric limit. So first we'll start with limit x tends to 0 sin x by x. So as we can see, if you put 0 in this, you'll get sin 0 by 0, which is a 0 by 0 form, and the value is 1 for this limit. We have a proper proof for this, but right now we'll be solving questions directly instead of doing a proof. Okay, so sin x by x proof is also there. The value for this is equal to 1. So this is the most important trigonometric limit and most used. Based on this, we'll be forming a different forms, and we'll be taking a practice on this. So limit x tends to 0, sine of 2x upon x. is. Okay, if you are planning to solve this by the method, see, this is how you solve. Yeah, limit x tends to 0. The formula for sine 2x is 2 sine x cos x whole upon x. Now as we can see, 2 is a constant, we'll take that outside. Limit x tends to 0. Sine x by x is the form, and this cos x is left. Now if you put 0 in this, or you just write like this, let's say limit x tends to 0, sine x by x, this limit, into limit x tends to 0 cos x. So we have separated a limit on the two functions. So 2 and this limit is 1, and if you put 0 in this, so it will be cos 0, and cos 0 is also 1. So 2 is the final answer. So limit x tends to 0, sine 2x by x is 2. So in this way, we'll just create a formula, or we'll just create a note point which will help us to solve the different questions based on the same pattern. Limit x tends to 0, sine of kx upon x, this becomes equal to k. Sine of, where k is any constant, so sine of kx upon x is equal to k. A very basic example based on this. Limit x tends to 0, sine of 4x upon x, the answer for this is 4. A very basic example just to show how to apply it. Okay, sine of 4x upon x is equal to 4. Now how this example will help us in many other formats and many other questions, we'll see. Before going to the next example, I'll just give you a note point or a formula. Cos x minus cos y, it is minus 2 sine x plus y by 2 into sine x minus y by 2. This is a formula that we are going to use. This is a formula that we are going to use it while solving questions based on this functions, cos x minus cos y. This is a trigonometric formula. Please note down this formula so that we can proceed on the next slide. Cos x minus cos y is equal to minus 2 sine x plus y by 2 and sine x minus y by 2. This is the formula. Okay, I'll directly give you a question based on this particular pattern. Limit x tends to 0, cos of 7x minus cos of 3x, cos of 7x minus cos of 3x upon x square. Okay, upon x square. So now let's solve this limit. First of all, if you put directly 0 in this, you will get cos 0 here, which is 1, cos 0 which is 1, minus cos of 0, again this is 1. So this 1 minus 1, which is 0, upon, if you put 0 here, it is 0 again. So 0 by 0 form is there. So again it is a trigonometry 0 by 0 form. So now let's apply this formula, cos x minus cos y. This formula, cos x minus cos y, here in the numerator. It is minus 2 sine sum of these two values, 7x plus 3x by 2, into sine of difference of these two values, 7x minus 3x by 2 whole divided by x square. Okay, so How is the formula? Sum of the two angles x and y. Sum of the two angles x and y by 2 and x minus y by 2. Okay. Sum of the two angles. This is x, this is y by 2, sum minus 2. That we have applied over here. 7x plus 3x by 2, 7x minus 3x by 2. Okay. Now limit x tends to 0. Minus 2. This will become 7x plus 3x is 10x. Upon 2 will be 5x. And 7x minus 3x is 4x. So upon 2 will be 2x. And this whole upon x square. This minus 2 is constant and getting multiplied. So I'll take this outside. Minus 2 is constant. It is getting multiplied. So we'll take outside the limit. Now we'll separate the limit like sine 5x upon x into the limit x tends to 0 sine 2x upon x. Now minus 2. What is the value of sine 5x upon x? It is 5. And sine 2x upon x, it is 2. So the entire question is now minus 20. It is minus 20. This 5x upon x, this limit, we have learned this format. We have learned this format, sine kx upon x when x tends to 0 is what? The number k. This format we have understood, that we have used here. And the same for sine 2x by 2 that we have used here. And this minus 2 was a part of formula again here. I hope this is clear. A very basic question. And now if you want, I'll give you a formula or a shortcut for these type of also. Okay. Let's write a note for this and let's use it in the previous example. Limit x tends to 0. Cos of ax minus cos of bx, this upon x square. The answer for this, or the shortcut for this is a b, right? So b square minus the previous term a square upon 2. Okay, so this term b square, this term b square here minus a square, this whole divided by 2. This is a shortcut. Let's apply that shortcut in the previous example here. So here it is b square 9 minus a square. A square means what? Let me just erase this part. So 7 square. 7 square is 49 upon 2. So as we can see, we are getting minus 20 directly. This thing. We are getting directly minus 20 just by applying the formula. So it is applicable on these patterns only. In this pattern only. If you remember, it will be helpful for your like objective exams. Cos ax minus cos bx upon x square is b square minus a square by 2. Now let's go ahead with a different pattern of a trigonometry. So what exactly we are going through? The different patterns. Like this was the first one. Okay, this was the second one. Okay, then we understood a formula, and then it came the third one. Okay, now let's look at the new pattern and the questions based on it. I hope till now whatever we have discussed is clear. Now the thing is, I'll just write limit x tends to a, any number, and inside the sign whatever 0 is becoming, okay, whatever the number is becoming 0, that 0 should be over here, same 0 along with this power, then we say answer is 1. Okay, so whatever is becoming 0 inside this sign, that same 0 will be here, and the power p should be on that. Okay, this will be more clear when I take an example. So sine square of, let's say, 3x whole upon x square. You have to find this limit. Okay, I'll do this limit with the process, and then we'll do it with this pattern or a shortcut like that. So by process, if you are going to solve, it is something like this. Sine square 3x means sine 3x into sine 3x, and we have a denominator में x square. Now if you separate this x square, sine 3x upon x into this sine 3x upon x. Okay, so we have two x squares. We are given one to each term. Now if you separate the limit again, limit x tends to 0, sine 3x by x into limit x tends to 0, sine 3x by x. So according to the pattern, the answer for this is 3 and the answer for this is also 3. Hence 9 is the answer. Hence the entire answer is 9. Now let's do the same question with a different method or a different approach or a logic. Here that we have done is with the previous one that we have understood. This one. Okay, now let's try with this different method. So as I said, limit x tends to something, let's say a. Something should become 0 inside the sign. Upon same thing should become 0 here, along with this power here. If it is there, then answer is 1. Now see, limit x tends to 0, sine square 3x upon x square. Now look at this number. This 3x is becoming 0. When x will be 0, 3x is becoming 0. It means this part is played by 3x over here. Okay, something becoming 0 means what? 3x becoming 0 here in this case. Now we need 3x का power 2 in denominator. Now we need इसका power p in denominator. Then we say answer is 1. When do we say answer is 1? The power of this part p should be here in denominator. So if you just observe it properly, the power of 3x, the 2 power, like this power, 3x square, it is actually what? 9x square. 3x square is actually what? 9x square. We already have x square in denominator. We'll just adjust 9 here and multiply 9. Again try to understand what I'm saying. ये जो 3x है इसका स्क्वायर डिनोमिनेटर में होना चाहिए. Whatever is written here, इसका ये पावर डिनोमिनेटर में होगा. Then the answer is 1. So now that we have created. Okay, it means the power 2 of 3x का power 2 is in denominator. Previously it was not there, like 9 was not there. So I have multiplied 9 and divided 9. This 9 is multiplied and 9 is divided. So now I can say this part, the limit of this part is 1 because it is in the above pattern. This limit is 1 and this is 9, hence the answer is 1 into 9, that is 9. I hope this is clear. We'll take few more examples. The entire concept is whatever written in the sign, the power of this p should be in denominator. Then answer is 1. So 3x का square 9x square है. Then we say answer is 1. Okay. I think I've over explained this. Now let's take some examples. Limit x tends to 0. Sine cube 4x upon x cube. So as we can see, let's start writing like this. It is 0 by 0 form. Sine 4x and the cube of 4x is 64x cube. So I'm multiplying 64 here and adjusting that. So this part we have multiplied and divided. Now if I can observe, this part is 1 and the answer is 64. Okay. Now let's take a different pattern again. So whatever we are learning in sine, the same thing is applicable for tan also. Whatever we have learned for the sine here, the entire part, same thing applicable for tan also. Let's take an example. Limit x tends to 0, 1 minus cos 4x upon x square. So again here note point. 1 minus cos of theta. It is 2 sine square theta by 2. Is 2 sine square theta by 2. Now if you apply the same formula here, and we can see that theta is 4x in this case. We can see this theta is 4x in this case. Okay. Two sine square theta by 2. It means 2x upon x square. Now 2 is constant. This 2. Sine square 2x upon x square. Now as I said, whatever is written over here, the power of this thing, I mean the 2x power 2 should be present over here. So it is not there, like 2x ka power 2 is 4x square. 2x ka power 2 is 4x square, but 4 is not here in denominator. So we'll adjust 4 in denominator. 4 I have multiplied and 4 I have divided. Now this part we can say limit of this part will be 1. So 2 into 1, the limit part, and the 4 which we have adjusted. Okay. This is what the value of limit is, and the answer for this is 8. I hope it is clear. Everything is clear. Hello Vaibhav. Hi. So this is a shortcut. Limit x tends to 0. 1 minus cos kx upon x square. The answer for this is k square by 2. So try to remember this part. Okay. Now let's take an example like this. Limit x tends to 0. 1 minus cos 6x into sine 5x upon x cube. Okay. Now try to solve this. Let's see if you can do it. I'll give you a 2 minutes or 1 minute time. 1 minus cos 6x into sine 5x upon x cube. I'll give you a minute. Just try it. first of all try to separate it something like this. 1 minus cos 6x upon x square sin 5x upon x. Now if you see the shortcut formula for the first part, tell me what is the answer. Look at the same formula written in the above part. 1 minus cos cx upon x square. So 1 minus cos kx upon x square, that is k square by 2. So let's apply that formula. K square by 2 means what? 6 square by 2. And the formula for this is what? 5. Okay. So it is 36 upon 2 into 5. 18 into 5. 90 is the answer. I hope it is clear. Now let's take one more. Limit x tends to 0. Sin 3x into 1 minus cos 5x. Sin 3x into 1 minus cos 5x upon tan 2x into sin square 6x into sin square 6. This is a mixed question I've taken. Okay. In this tan, cos, everything is there. Now in this question again the pattern is given more important. Okay. What is the pattern thing? Again try to understand. Limit x tends to 0. Sin 3x. I am adjusting a 3x over here. So whatever is written in this case, that power 1, whatever is inside the 0, a sign, that with this power should be in the denominator. So I adjusted the 3x. 1 minus cos 5x, I have adjusted the x square. Now to nullify this, let's multiply 3x over here and x square over here. This is to nullify it. We have adjusted or we have multiplied in denominator. Wait, let me write it again. This is 3x into x square. This is multiplication. This whole divided by, for tan 2x we'll do the same thing as we did for sin. So 2x ka adjustment, we'll adjust this 2x here. And for sin square 6x, the square of this part, that is 36x square, should be in denominator. Okay, 36x square should be in denominator and into 36x square. Again I am going to that part. Please focus on this. Okay, this is more important. Whatever is written here, the power of that thing, power p, should be in denominator. Then only answer is 1. Answer is 1 when यहाँ जो भी लिखा है उसका पावर p डिनोमिनेटर में रहना चाहिए, तब 1 होगा. तो इन दैट केस 36x square, 6x लिखा है, 6x का पावर 2 we are adjusting over here. Now limit x tends to 0. So this sin 3x into 3x, this is 1. This is k square by 2. This is 3x. And this is x square upon this part again becomes 1. This part becomes 1 and 36 x square. So if you observe, x square gets cancelled, x gets cancelled, Okay, what is left now? So 25 by 2 and this 3. Okay, 3 and this also gets cancelled, 12. 25 by 48. I think today we have done enough practice on the limits. 2 or 3 shortcuts also are discussed. Okay, in that case we should stop here, and if possible you comment in the comment box whatever you want to learn more regarding the limits and all, or any other chapter. Till that you can use my code RMSIR on the Unacademy application, Unacademy Plus application, and also you can enroll for the Plus course. This will give you 10% off when you use this code. Okay, goodbye.